Okay, I've got another revision question here that I tend to give my students, and it's really based in the normal distribution. If you want to have a go at it, pause the video and then unpause it and we'll do the solution. Okay, so workers at a factory have travel times normally distributed, a mean of mu and a standard deviation of sigma. It's found that 11.4% of the workers take less than 6 minutes to get to work and 78.8% take less than 10 minutes. Find the mean and the standard deviation. So what I'm going to do, the key to this is to draw a good diagram. So I'm going to get my diagram here. This is my normal distribution, and it's only a sketch. It's going to be something like this. And it says 11.4% of the workers take less than 6 minutes. So here, 11.4, this probability they take less, 11.4 is this, and this is 6 minutes. In the middle here is mu, which I don't know. And we've got this other bit, 78.7 take less than 10 minutes. Now this is more than halfway, so this is 10 minutes, has to go here, so that this big probability here, including the bit at the end, that's 78.7, 0.787. Now what I want to do is I want to standardize all these values. So when I standardize mean, I get 0. When I standardize 6, I get a value here, the z value, and it comes from this probability. So how am I going to work that out? I'm going to go to stat, and I'm going to go to distribution, normal. I've got the area. Whenever I've got the area, I use the inverse norm, and my tail is indeed on the left. The area is 0.114, and I'm now going to say that this sigma is 1 because I'm using standardized data, and this is 0. So this is the z value. Again, do you want to have a look at that? That's left, 0.114, 1 and 0 the key, and I get minus 1.2055. Now I'm going to do a similar thing with the 10. So I'm going to go back. I'm going to say my area is still on the left, but my probability is 0.787, and this gives me 0.7961. Now these are z values, standardized values. Now I have a formula for standardized values, which is to take the x score, take away the mean, and divide by the standard deviation. So my z score I've got here, let's do the positive one first of all, 0.7961 equals, my x is this value here, so that's 10 take away mu divided by the standard deviation. So if I were to rearrange this, I'm going to get 0.7961 standard deviations plus mu, and add that to both sides, equals 10. Now I'm going to do exactly the same with the other one, and I'm going to go minus 1.2055 equals, now this is 6 minus mean divided by standard deviation. So this is negative 1.2055 sigmas plus the mean, the mu, and it equals 6. Now I've got it like this. It's a graphic calculator question. Go to menu, go to equation solver. We want a simultaneous equation. Two things we don't know. So the first one we put in is 0.7961 and 1 mean, and this is 10. And on the second one, minus 1.2055. So sigma is first, and the mean is second. So my sigma value to the nearest whole number is 2, and my mean is 8.41. Let's just double check. Mean correct to one decimal place, standard deviation to the nearest whole number. So standard deviation, and I don't want the 1 to the nearest decimal place. So it's 8.4 and 2. The key is have a good diagram and understand about the Z numbers and the standardized values and how I can get these standardized numbers from the area.